On a dark road near Zurich, Switzerland,
It's coming down very fast.
a fireball lights up the sky.
It was a hell of an explosion.
The crash of a Swiss commuter plane kills everyone on board.
Give me that one there.
Air crash investigators face an enormous challenge trying to piece together what went wrong.
That timing can't be coincidence.
498, turn left to Zurich East.
Suddenly, he loses control.
Oh, no.
What triggered it?
Evidence from the crash site points to a stunning possibility.
We're not supposed to take any kind of drugs when we go flying.
The pilot may not have been in any shape to fly.
Mayday.
Zurich International Airport. Passengers on board Crossair Flight 498 are waiting to take off.
Ciao. Sì, ho capito.
The flight to Dresden, Germany is popular with business travelers.
Ciao. I'm sorry, I'm done.
It's one of more than 100 destinations served by the fast-growing Swiss airline.
It's a regional airliner, very popular for short hops from town to town.
In the cockpit are two pilots who've come to work in Switzerland from Eastern European countries.
You ready?
Captain Pavel Gruzin will fly the plane, while Rastislav Kolesar acts as first officer.
Checklist completed.
Rastislav Kolesar loved flying very much.
Former Crossair pilot Slavomir Piatak was a close friend of Kolesar.
You could see sparks in his eyes when he was speaking about flying. You know, he changed the look in his face. He was smiling, you know. He was very passionate about flying.
Set takeoff power.
Takeoff power set.
The plane they're flying this evening is a Saab 340.
Saab 340 is a Swedish-built commuter airplane. It had a digital autopilot, which was able to fly very accurately.
B1. Rotate.
Gear up.
Gear is up.
The airplane was easy to handle and smooth under controls.
The flight is scheduled to take about an hour.
After, let's say, 2 or 3 minutes flight time, they should have been in the clear above the clouds to fly to their destination.
At the last minute, the controller makes a slight change to their flight path.
498, turn left to Zurich East.
Turning left to Zurich East, crosshair 498.
The new route loops them south of the airport and over a navigation beacon before going on to Dresden.
Long range navigation setting is to Zurich East. Yeah.
Check.
The plane begins to turn. But something's going wrong.
Turning left to Zurich East. We should left. Oh, no.
Crossair 498, confirm you are turning left.
Please, stand by.
The plane should be turning left, but instead it's banking to the right.
Okay, continue right to Zurich East.
Captain Gruzin struggles to control the plane, but it's not working. They're falling out of the sky.
And I was driving home. And then on the left-hand side, I've seen something. I was sure it's a plane. It's coming down very fast. It was a hell of an explosion. I've been about 50 meters away from this, and it was just one explosion and then always a new, smaller explosion. I couldn't go too close there. It was too hot.
It's impossible even to attempt to rescue anyone.
I couldn't see anything from the plane, just the little small things. And this time, I was quite sure there's no survivors, not at all.
Flight 498 has slammed into the ground just 7 kilometers from the airport. All 10 passengers and crew are dead, including Pavel Gruzhin and Rastislav Kolesar.
At that very night, we just knew that we lost a friend.
The next morning, investigators are at the crash site. They see little that resembles an airplane.
When I approached the scene, I saw a smoking hole. And I couldn't identify a larger piece of structure of an aircraft.
Michael Flukiger is with the Swiss Accident Investigation Board. It's his job to find the clues that can explain what happened. Most of the plane is buried in a deep crater. The rest is broken into small pieces scattered across a field. Flukiger faces the biggest challenge of his career.
You have really a mess. And then you have also the emotional part. You don't know what you're going to touch next. It may be a piece of a human body, it may be a piece of the aircraft, or it was a hard chore.
The deep crater tells Flukiger that the plane hit the ground very fast, at a very steep angle.
A photo takes this shot here.
If you can't see a bigger structure of an aircraft and you see a crater, that leads you to the idea that this aircraft has to come quite steep into the ground.
The pattern of debris also reveals the direction the plane was flying. Flight 498 was turning the wrong way at the time of the crash. Human factors expert Daniel Connect joins the investigative team.
A crash just after departure is very uncommon. So we were sure that it must have been something very unusual.
Let's get someone over to the ATC, find out what departure they were flying.
Investigators question air traffic controllers to learn more about the unusual flight path.
If you have a radar plot and also some recordings of air traffic communication, then you have a first idea what happened.
Why weren't they flying the standard departure?
Oh, I was just trying to save them some time.
Controllers tell investigators that they gave Flight 498 a shortcut on the night of the crash.
498, turn left to Zurich East.
The new heading was a slightly shorter route to Dresden.
ATC controllers, they provide this kind of shortcut whenever they can.
Turning left to Zurich East.
And that makes a difference of about 3 to 4 minutes, which is very much appreciated by the pilots and everybody else.
At the first glance, this communication and also this radar plot showed nothing unusual. There was simply a takeoff, then ATC was commanding an early left turn.
But for some reason, the crew didn't follow the controller's instruction.
Crossair 498, confirm you are turning left.
Please, stand by.
The controller assumed the pilot wanted to follow a different route and approved that decision.
Okay, continue right to Zurich East.
Moments later, the plane fell into a deadly spiral to the right. If the spiral was caused by a mechanical failure, investigators need to know as soon as possible. A problem with aircraft maintenance or a design flaw in one of the parts could mean that thousands of passengers flying on the Saab 340 are at risk every day. At the crash site of Crossair Flight 498, investigators search for evidence of a mechanical failure. Witnesses report seeing fire in the sky moments before the plane hit the ground.
Show me how high the plane was when you saw the flames.
We had the impression that there could have been an in-flight fire because there were some people who were describing an aircraft burning before impact.
Any sign of the black boxes?
The answers investigators need may lie in the plane's 2 flight recorders.
Turning left to Zurich East.
They capture vital information about what the pilots say and do in the cockpit.
Crossair 498.
But so far, there's no sign of them.
We made a plan to go layer by layer and take the pieces, and one day the FDR and CBR may come up to light.
APR off.
Meanwhile, questions are raised about the 2 pilots' ability to communicate.
Climbing level 110.
English wasn't either pilot's first language. Perhaps they were off course because they didn't understand the controller's command.
APR off.
It's coming.
One of the most important things in working together in the cockpit is communication.
Long-range navigation setting is to Zurich East. Yeah.
Fluency of a common language is of utmost importance.
Investigators study the pilot's records.
They look very experienced.
The records are spotless. Both men are well qualified and can speak enough English to fly a plane.
I flew with both of them. I knew Rasislav's English. He was very good. I could talk to Pavel, and he understood. He responds very well.
Investigators are no closer to understanding why the pilots turned the wrong way and lost control of the plane.
A steep right turn developed, which led to a collision with ground. But there was no indication about the reason for that.
Search efforts at the crash site bring the team a big step closer to understanding what happened in the cockpit. They recover both black boxes. The crucial recorders are sent to the lab for analysis. Meanwhile, the rest of the wreckage is taken to a hangar in Zurich. Perhaps a mechanical failure can explain why the plane spiraled out of control.
At this point of the investigation, a malfunction was a major point of discussion because it would have been an explanation for this loss of control.
Investigators study damaged parts from the engines.
If an airplane spirals down from the skies, a possible engine failure could be one of the reasons.
The Saab 340 is powered by 2 turboprop engines.
If you have 2 engines, one each side of the aircraft, and if, for instance, the left engine provides you with more power than the right one, the aircraft tends to turn to the right.
If the right engine failed, it could explain the fatal spiral.
Spinning at high speed.
But both engines show distinct damage that can mean only one thing.
It was quite clear in just a short time after the accident that the engines were running, and they were running even on high speed.
Engine failure did not bring down Flight 498. Investigators dig through the plane's maintenance records in search of a solid lead.
I think I've got something. See here, and again here.
The airplane had a history of uncontrolled flap movement.
In the last 18 months, crews lodged more than 20 complaints about the flaps on this very plane.
It's a lot of complaints.
21 in 18 months, that catched our interest.
Flaps are small surfaces that extend from the back of the wing during takeoff to increase lift. If the flaps on one wing don't extend properly, it can make the plane hard to control.
If something is wrong with the system and one flap is moving faster than the other or going further than the other, you're inducing at this wing more lift but also more drag. So that will tend you to roll in this left or right direction.
Evidence of a flap malfunction on Flight 498 could be the break investigators need. They sort through fragments of wing wreckage, but it's no use. The parts are too badly damaged to provide any answers.
They were damaged in, I don't remember in how many pieces. The actual flap was destroyed.
They won't know for sure if the flaps malfunctioned until they can study data from the flight recorder. But the wreckage does allow investigators to explore a different theory. Witnesses reported seeing a fire on board before the plane hit the ground.
So that was quite interesting that the eyewitnesses told us that they saw the aircraft in flames. That made us curious. So we need to go to the wreckage and make an investigation.
Flames leave distinctive scorch marks on the skin of a plane.
Give me that one there.
If the plane caught fire before the crash, debris from the same part of the aircraft should show the same pattern of soot marks, much like neighboring pieces of a jigsaw puzzle. That's not the case if the fire started when the plane was already in pieces.
If you have a fire after the accident, those pieces may be already split up, and they don't match, the fire traces don't match anymore.
It's a painstaking procedure. Investigators must map each piece of debris to a precise location before they can compare the burn marks. In 1991, burn mark analysis helped investigators in Saudi Arabia understand the crash of Nation Air Flight 2120. After a wheel caught fire on takeoff, the DC-8 became engulfed in flames. None of the 261 people on board survived. Now, Swiss investigators struggle to determine if an in-flight fire brought down Crossair Flight 498.
It took us also a long time to find all the pieces.
The results are conclusive.
See here and here? The scorching was definitely post-impact.
At the end, we could determine that it had a post-impact fire, that's for sure.
The witnesses are wrong. There was no in-flight fire.
Witnesses often tell us some observations, but it's not necessarily in the right order, chronology. That's quite often the case.
Crash site debris soon produces another lead. A pilot's flight bag was thrown clear of the crater on impact. It's quickly identified as belonging to Captain Gruzin. The contents are disturbing.
There were some personal items in there, and with them we found this medication.
No label or box with it?
It is quite uncommon that you find some medication in a pilot's bag.
Turning left, Zurich East. We should left.
A drug-impaired pilot could explain the accident.
It is always of great concern because we all know that we're not supposed to take any kind of drugs when we go flying.
Investigators need to know exactly what type of drug they're dealing with, and whether Captain Gruzin took any on the day of the crash.
It is to the lab.
Tests reveal that the medication is phenazepam, a powerful sedative similar to Valium that's used to treat anxiety disorders.
In this case, there was a medication which was very strong and which can have an effect on your capability to fly an airplane.
Daniel Connect may finally have found the reason why 10 people died on board Flight 498. Figuring out if the drug was in the captain's system will require tissue analysis. That will take more time. But valuable new information has been recovered from the plane's flight data recorder.
Let's see what this looks like.
Investigators use the data to create a simulation that replicates the plane's motion during the flight. They hope it will tell them if malfunctioning wing flaps led to the crash.
Set takeoff power.
Takeoff power set.
A physical examination of the flap panels was not possible anymore, so we needed to find another way.
Flaps affect lift and drag. If there was something wrong with them, it will show up in the simulation.
APR.
Crosshair 498. Climb to flight level 110.
Climbing level 110.
Crosshair 498.
The plane climbs normally.
Climbing to 3,000 feet.
There's no sign of any flap malfunction.
We could rule that out at this point.
Please are on.
The flaps were working as they were designed.
No problem at all.
We saw the engine were running, we saw we have a good speed, everything is climbing, everything is going good. And suddenly, he switches from a left turn to a right turn and he loses control.
Oh, no.
It's like no one is flying.
The big question is why? What happened?
Investigators travel to Moldova to meet with the captain's widow. They ask her why her husband was carrying tranquilizers.
I'm sorry, I know this is a difficult time.
She explains that her husband was under a lot of stress.
She knew that he was taking this medication. And it was, I think, also due to the situation that he was separate from her, living in Switzerland.
The captain was working far from home and sending money to his family in Moldova.
He was not very happy to be separate from his family, from his spouse, from all the people he knew. He was in another country, able to speak English, but not German or French. And I think this was not easy for him.
But was Captain Gruzin unhappy enough to risk taking a tranquilizer before piloting a commercial flight? Investigators hope the tissue analysis will tell them if the captain was impaired when he took off from the Zurich airport. The results are inconclusive. Though he had traces of the sedative in his system, the tests can't reveal if it was enough to affect his flying.
We were not able to rule out this effect in the accident, but we were also not sure that this medication had an effect for sure.
But investigators aren't giving up.
Oh, no.
There may be another way to determine if the captain was impaired. A friend of Captain Gruzin is brought in to help with the investigation.
So, just have a listen and see how he sounds to you.
He's asked to listen to conversations captured on the cockpit voice recorder.
He's ready. Checklist completed. Set takeoff power.
He listens for any hint about how the captain was feeling, any sign that he was impaired when the plane took off.
Takeoff power set.
The tone or the pronunciation, all those things are very important. For example, if you have people who are under medication, if pronunciation is not so clear, this could be a clue.
APR off.
How about that? Keep listening, be sure.
Lead on. Leads are on.
But the captain's friend hears nothing out of the ordinary. Gruzhin's voice sounds completely normal. There's no sign at all that he's impaired by drugs.
The behavior, all the discussion was very calm.
Okay, one more time.
Investigators are running out of leads.
Checklist completed.
The cockpit recording seems to offer little, until...
Set takeoff power.
Hold on.
Power set.
Play it back.
they hear an odd sound.
Set takeoff power. Takeoff power set.
Sounds like cell phone interference.
We had some indication on the CVR that there was a cell phone working in the airplane.
In the year 2000, there's a potential new threat to aviation safety. More and more people are carrying mobile phones, and their effect on planes is unknown. When a mobile phone is in use, it transmits a signal to the mobile phone tower and can create interference. The signal has been captured as a buzz on the cockpit voice recorder.
Takeoff power set.
Investigators wonder if interference could also have affected the plane's instruments.
There are malfunctions where you don't have any indication about the malfunction. The instrument is showing a normal indication. This kind of malfunction is very difficult to detect.
Cross Air 498. Climb to flight level 110.
Climbing level 110, crosshair 4908.
Commercial pilots rely almost entirely on their instruments to tell them their plane's position in the sky.
The main instrument to follow is artificial horizon, an instrument that gives you the idea of climb or descent, and also the indication of bank, left or right bank.
If mobile phone interference affected the artificial horizon, it might explain why the pilots didn't know they were turning the wrong way.
Oh, no.
Investigators learned that a Slovenian airliner was forced to make an emergency landing after mobile phone signals caused the plane's electronics to malfunction, triggering a false alarm about an onboard fire.
It can influence the aircraft systems, more or less send you messages that are not true.
There's no question there were mobile phones on board. Crossair pilots even carry one in the cockpit to communicate with the ground crew. Investigators set up a series of tests in an identical plane.
Okay, we're all set here. So, go to the back and trigger a signal.
They look for any sign that a mobile phone signal can affect vital flight instruments.
With this test equipment, you can emulate a cellular phone. And we went close to the avionics racks. We tried to stimulate the system.
Nothing yet.
Try again.
There are mobile phones on nearly every plane in the sky. If mobile interference really is the cause of the crash, investigators need to know before it happens again. Investigators obtain the mobile phone records of every passenger on the plane. They check to see if anyone on board used their phone in the critical last moments of the flight.
Nothing yet. You?
Cell phones normally don't do any damage or any harm to aircraft systems because they're very well shielded from such electronic interference.
The onboard testing confirms that mobile signals can create electronic interference in the cockpit.
There it is.
But can that interference cause flight instruments to malfunction? After repeated testing,
Try again.
investigators can find nothing to support that theory.
We didn't have any evidence that the cellular phone was a problem.
The phone records show that all mobile phone calls to and from the plane ended before takeoff.
Jump, jump, jump.
During the flight, we had no communication between one of the cell phones and ground stations.
It now seems that other than the noise captured on the CVR when the plane was still on the ground, mobile phones had no effect on the flight at all.
The result there was simply zero.
None of the theories are panning out. Investigators re-examine the best evidence they have, the pilot's comments recorded in the cockpit,
Gear up.
and the information from the flight data recorder.
Gear is up.
APR off.
Crosshair 498. Climb to flight level 110.
Climbing level 110, crosshair 4908.
APR off. It's coming.
They listen for anything that can tell them how the instruments were working that night.
Right here, the turn is starting to get very steep.
Turning left to Zurich East. We should left.
Oh, no.
A sudden reaction from the captain provides a clue.
That timing can't be coincidence.
Investigators know that the captain's flight display changes in appearance the moment a turn gets too steep.
The system is designed that if you go into an abnormal bank or pitch angle, he removes unnecessary information to make the recovery easier for the pilot.
This was just at the moment when the captain was commenting this "oh nana."
The timing of the captain's remark convinces investigators that his instruments were working, but that he didn't understand what the gauges were telling him.
People who are confused are not detecting this confusion at the moment. I think the problem was that he was not aware what was going on.
The search for an answer takes investigators to Russia, where Captain Gruzhin learned to fly.
Thank you for seeing us.
They meet with Russian aviation experts. Crossair recruits many pilots from the former Soviet Union. If Russian training is faulty, lives could be at risk.
Crossair was expanding dramatically with no resource of own pilots from Switzerland or neighboring countries, so it was very easy for pilots to transfer to Crossair airplanes.
They study the pilots' histories before they move to Crossair. Captain Gruzhin was 41 years old. He had over 8,000 hours total flying time and almost 1,900 hours on the Saab 340. The 35-year-old first officer, Rostislav Kolesar, had more than 1,100 hours in the plane.
He was a very capable pilot and well organized.
Both pilots were highly qualified. There seems to be no reason to suspect pilot error, until the Russian investigators suggest a stunning theory that could change everything. They tell investigators about a troubling cluster of accidents caused by Russian-trained pilots becoming confused by a crucial flight instrument.
This was very surprising for us because this problem was not well known at this time in the western part of aviation.
Pilots in the Soviet Union were trained to fly using an artificial horizon that looks very different from the one used in Western planes.
Turning left to Zurich East, crosshair 4908.
In the West, the airplane symbol in the middle remains stable as the background moves. Soviet horizons work in the opposite way. The airplane symbol shows the motion, and the horizon is fixed in place.
It's easy to see how a pilot might get confused.
A left turn on a Soviet display looks very similar to a right turn on a Western display.
There were two different philosophies of artificial horizons in the Western aviation system and in the Eastern aviation systems. And these two systems, they can lead to a certain confusion.
As countries in Eastern Europe began buying more Western planes, that confusion proved deadly. 15 crashes involving spiral dives.
This discovery was really crucial for the probable cause of this accident.
Under stress, and possibly under the influence of a tranquilizer, Captain Gruzin may have fallen back on what he had learned when he first became a pilot.
No! What you learn at your first, very initial training, it goes back to your reptile brain. Is where you really store in a long-term memory basis. That's what you remember, and you go back to your basic training.
In his confusion, he became convinced he was in a steep left turn. He was turning right to try to correct that problem. The air traffic controller only added to his confusion.
Crosshair 498, confirm you are turning left.
The instruction may have seemed like confirmation that the plane was turning left, even though it was not.
He said 498, confirm you're turning left. How much does that help to a crew?
Please, stand by.
The only thing he could have done, in my opinion, is to say either Crosshair 498, turn left, heading whatever, or Crosshair 498, I see you in a right turn.
Left! Left!
What he actually said didn't help anybody.
The captain's constant attempt to level the plane he believed to be turning sharply left actually put the aircraft into a deadly spiraling dive to the right. Investigators also discover another important difference between Russian and Western aviation.
That is a lot of hand flying.
Russian pilots have a different approach to the use of the autopilot.
Long-range navigation setting is to Zurich East. Yeah.
The autopilot can fly the plane,
Okay.
even if both pilots have their attention on other tasks.
Eastern philosophy from the previous Soviet Union would be to fly the aircraft as long as possible with hand flying, just to prove the ability for the pilot to fly. And that's really different from the Western philosophy.
The captain of Crosshair 498 was flying by hand. The autopilot was not engaged.
If the captain had engaged the autopilot after takeoff, the accident would not have happened.
We would never have talked about this flight because the airplane would have simply flown to Zurich East and reached Dresden about 1 hour later.
But there's another troubling question. There were 2 pilots on board that day, even if the captain was confused by his instrument. Why didn't the first officer notice the problem and take steps to save the plane?
If somebody sees something going wrong, then he should intervene.
Pass me the specs for the Crosshair fleet, would you, please?
Investigators wonder what could have prevented First Officer Kolasar from noticing his captain's mistake.
Climbing level 110, crosshair 4908.
It was the first officer's job to monitor the instruments.
APR off. It's coming.
But he had an extra challenge during Flight 498.
498, turn left to Zurich East.
Turning left to Zurich East.
Crosshair 4908.
The plane's computerized navigation system was a new addition to the cockpit. Cockpit design is a complicated process. Pilots need to be able to reach everything easily, as well as monitor a vast array of instruments, including the artificial horizon located directly in front of them.
The Saab 240 is not a huge aircraft. You don't have space to place everything in the optimum area, so it's a challenge to organize the cockpit.
Investigators wonder if an awkward cockpit design made it difficult for the first officer to see what was going on. To find out, they conduct an unusual experiment.
Okay, let's begin.
B1.
They reconstruct the flight
Rotate.
to see exactly where the first officer was looking when things started to go wrong.
Gear up. Looking at the gear handle.
Gear is up.
APR. Crosshair 498. Climb to flight level 110.
Climbing level 110. Crosshair 498.
After takeoff procedure for Sub 340 requires from a pilot which is not flying to do most of his job either head down or head up. He would either follow the overhead panel to put the switches in a proper position or would look down to turn the knobs and try to settle the center pedestal panel.
Set climb power.
Coming.
His duties keep his gaze away from the artificial horizon.
Now he's looking here. Now I can look up.
By the time the first officer could see what was happening, the plane was already in a steep right bank.
Turning
Left to Zurich East.
If you do not pay attention when you look back, you will probably find an attitude you didn't expect. Researchers found out that it takes 4 to 18 seconds to have an idea what the airplane is doing, what kind of attitude the airplane actually is, and what kind of action has to be taken to recover from it.
We should left.
Crosshair 498. Confirm you are turning left.
Please, stand by.
It was clearly detectable that the stress was increasing.
No!
The first officer's stress shows he knew there was a serious problem.
Left!
The captain thought his plane was turning left. He didn't understand what his first officer was trying to tell him.
Their English was basically aviation English, and it is hard to communicate fluently and to communicate concerns well enough.
All you had to say was stop, you're turning the wrong way.
It is normal in aviation that you have an exchange of people from different countries. And I think that's a nice part of aviation, that it is international. But you have to analyze their cultural background. You have to give them the tools they need to do their job safely.
After the crash of Flight 498, the airline improved training for pilots from former Soviet bloc countries. They now get 3 months of extra instruction. They also must pass an English proficiency test.
Everybody's working hard to make good aircraft with good trained people, good aircraft systems.
Finally, all Swiss crews are now required to engage the autopilot immediately after takeoff, ensuring that they can pay proper attention to the progress of the flight.
Next up, meet 19-year-old Vedant Mungi, who is having surgery to remove up to 85% of his stomach in brand new half-ton world after the break.